Solving division problems. Learning goal. I can recognize, solve, and create problems that involve division. Complete this statement to create a division problem. There are 482 students in Rashed School. They're basically looking for us to create an example type of problem. So here's an example. There are 482 students in Rashed School, and 85 of them play basketball. How many teams of 5 would that make? And the answer, of course, is 85, and we divide it by 5. Or, there are 482 students in Rashed School. If they are separated equally into 12 different locations for fire drills, how many students would be in each location? The answer is 482 divided by 12. Or another example, there are 482 students in Rashed School. There are 3 times as many students as in Ashley School. How many students are in Ashley School? The answer, 482 divided by 3. Volunteers at the library are putting children's books in packs for young families. The family packs will be sent in equal numbers to different community centers. They give us some numbers here, and we're asked to fill in the blanks. Choose a value for the missing digit in the total number of family packs that the volunteers will make. So I'm going to choose 224. Then we're asked to choose a number of 15, 16, 27, or 28 for the number of community centers. And then finally to determine how many family packs they can make for each community center. So this is what we're trying to find. We're going to take the number 224 and divide it by one of these numbers that they've suggested. I'm going to choose 16. So we take 224 and we divide it by 16. I'm going to use the partial quotients method for doing my calculation. And I'm going to start off with saying, okay, I'm not really sure how many 16s would go into 224, so I'm going to start with 10. 10 times 16 is 160. Subtracting 160 from 224 gives me 64. Now, number of 16s that go into 64, I'm not really sure. I'm going to guess at 4. 4 times 6 is 24. 2 to carry. 1 times 4 is 4, plus the 2 is 6. Oh, I guessed right. So I've got a remainder of 0. I can now add up my 10 and my 4 to get 14. So there are 14 packs for each community center. We're going to solve the same problem for question 1 again, using the same total number of family packs, but a different number of community centers. So we said 224. Last time we said there were 16 community centers. This time we will say there are 15 community centers. So in this circumstance, we're going to take 224 and divide it by 15. We'll use the more traditional method of dividing this time. We ask the question of how many times does 15 go into 22? There's 1 15 and 22. 22 minus 15 is 7. And we bring down the 4. Now, how many 15s in 74? I'm not really sure, so I'm going to go ahead and I'm going to guess 6. 6 times 5 is 30. 3 to carry. 1 6 is 6, plus 3 is 9. Whoops, this number is too big. So clearly 6 wasn't a good guess. Let's try 4. 4 times 5 is 20. 2 to carry. 1 4 is 4, plus 2 is 6. So I've got 74 minus 60, which leaves me with 14 remainder. So if there were 15 centers and 224 family packs, there would be 14 packs for each center, with 14 left over. Question 3. There are over 500 family packs of children's books to send to community centers. How many packs can go to each center if they are shared equally? So there are over 500 family packs, and we're asked to fill in the numbers, so we'll go ahead. I'm going to say there are 538 family packs. This is the number that we're trying to find, and we're supposed to use the same number of community centers, which last time was 15. So in this circumstance, I've got 538 divided by 15. Using the traditional method of dividing, 3 times 15 is 45. 53 minus 45 is 8. Bring down the 8. Number of 15s that go into 88. 5 times 5 is 25. 2 to carry. 1 5 is 5 plus 2 is 75. 88 minus 75 is 13, and that's our remainder. So, each community center will get 35 packs, and there will be 13 left over that aren't distributed. Create a division problem. You should be able to solve it using the calculation you did in question 3. It should involve comparing two quantities. You know the larger number and how many times larger it is than the smaller number. You need to figure out the smaller number. So an example might be, the librarian has 538 books to put away. That's about 28 times as many books as he put away yesterday. How many did he put away yesterday? What operation did you use to solve each problem in the action task, and why? Your response might be that you used division. I was either making equal numbers of packs and figuring out how many centers, or figuring out how many packs per center, if I knew the number of centers. Both are about making equal groups. What operation would you use to solve your problem in action question 4, and why? Again, an example answer might be division. I know a bigger number and how it compares to a smaller number, so I can divide to figure out the smaller number. How are comparison problems like grouping problems? An example response might be, if a number like 538 is 28 times another number, it's because 538 is the same size as 28 groups of the smaller number. Why can you multiply to check your answers? An example response might be that I solved each problem using division, and multiplying is like reversing division. If you divide a big number by a small one to get an answer, you can multiply the answer by the smaller number to get back to the big number. If there's a remainder, you have to add that at the end to get the big number. Why is estimating a good idea? Well, an example response might be, it's another way to check to see if your answer is reasonable, and you can do it in your head because you use easy numbers. Why are there so many strategies for calculating the answer? An example response might be, there are a lot of different ways to break up a number to divide it into parts. Or, there are lots of different ways to divide, including the standard algorithm. How does breaking a number into parts help you calculate? An example response might be, you break it into parts that are easy to divide by the other number. Why is it possible to create many different problems for the same calculation? The calculation just tells you how many things there are in total and how many are in each group, or how many groups there are. It doesn't tell you anything about what those things are. Or another response might be, you divide to share into some number of groups, or group into equal groups of some number, or compare two numbers. Lesson summary. What is one thing that you learned about solving division problems in this lesson? An example response might be, I can divide to solve problems involving sharing a total into equal groups, making groups of a certain size, or comparing numbers. Another response might be, I need to think about the problem situation to decide what to do with the remainder. There are many different problem situations that can be solved by dividing. For example, sharing a total into some number of equal groups. Here's an example. There are 105 kindergarten students and 5 kindergarten classrooms. How many students will be in each classroom? Dividing a total into groups of some number. A typical month has about 30 days. About how many months are there in 700 days? Dividing a number by how it compares to another number to figure out the smaller number. The police gave out 430 speeding tickets this year. That's about 12 times as many as last year. How many tickets did the police give out last year? Now, what do you do with remainders depends on the answer and the problem you're solving. You might ignore the remainder. You might round down or up to the next whole number. You might mention the remainder in your answer, and you might represent the remainder as a fraction. You can estimate or multiply to check a division calculation. For example, to check 146 divided by 16, which is equal to 9 with a remainder of 2, you start off by multiplying the 16 times your 9, which gives you 144, and then you add the remainder, which is 2, to get 146, so that confirms that your answer is correct. Another estimation method, to check 365 divided by 7 is equal to 52, with a remainder of 1, we might start off with saying, well, I know that 350 divided by 7 is equal to 50, and the reason I come to that conclusion is because I know that 35 divided by 7 is equal to 5, so 350 divided by 7 is going to be equal to 50. And since 365 divided by 7 is just a little bit more, the number that we've got here, 52 with a remainder of 1, seems reasonable. It doesn't give us the same accuracy when we actually worked out and did the exact calculations for multiplication and addition, but it still gives you a good indication that your response is correct. Some key terms. Quotient is the result of dividing. For example, in 20 divided by 5 equals 4, 4 is the quotient. Remainder. The remainder is the number left over when you divide. For example, in 365 divided by 5 equals 7 with a remainder of 1, 1 is the remainder. Whole numbers. The counting numbers and 0, for example 0, 1, 2, 3, are whole numbers. They do not include any fractional part or a decimal part. Your turn.